morning. We're on to lesson 6 notes, equation of a sinusoidal function, part 1. So we're going to relate the graph to the equation now and see how different graphs of sinusoidal functions relate to their equations. On the top here, I have the general form of a sine or cos function. So we can see that we have three variables here, A, B, and D. There is actually a C, but we don't talk about it in this course, so I might mention it a bit later on. A actually represents the amplitude. So if you have a number in front of your sine function, it's going to correlate directly with your amplitude. B is something called a horizontal stretch. We're going to get into that in the next lesson. And then D is your vertical displacement. So we learned those terms in our last lesson, and now we're going to see how it impacts the equation. Today we're going to talk about the A value and the D value, and then next day we'll finish off with the D value. So we mentioned before about amplitude. Usually if you have the graph, you can actually see it and count what the amplitude is. It's the distance from the peak to the midline of your graph. Or if you're not sure, you can always use this equation too. It's your max value minus your min value divided by 2. One thing we haven't mentioned though is let's look at this equation here. So this represents my A value. That's telling me that my amplitude is equal to 3. The negative sign here tells you about your graph. What it does is it basically flips your graph upside down. The math terminology is it vertically reflects your graph over the x-axis. So instead of your sine curve going up first and then down and then up again, it's going to go down first and then up and then down again. It's just going to be like a mirror on your x-axis and flipped down. So keep that in mind with the negative. We might throw one or two of those in there just to test you with that. So let's look at an example here. I've given you an equation of a sine function, and I want you to find the amplitude. Your amplitude is always the number in front of the sine or cosine. In this case, it's 3 over 2. You do not write the negative, because amplitude is an amount. It's how high something is. The negative doesn't make sense in that. The negative just tells us that we're flipping it upside down. Then we can also calculate the range. Once you start throwing in a bunch of numbers, it's a little difficult to try and figure out the range, so I'll give you kind of some tips in how to do that. Remember, range though is your y values, how high and low your graph is going to go, which is directly related to your amplitude. So what you'll see is, in general, your range is going to be your minimum value of your graph to your maximum value of your graph. Some graphs, that's easy to see if you actually have it, but maybe I'll just give you an equation and ask you for the range, and if you don't want to take the time to graph it, we can still figure it out. Your minimum value is actually going to be your vertical displacement minus your amplitude, right? That makes sense. Your vertical displacement is your midline, and take away the amplitude, that's going to give you your lowest point on your graph. And then your maximum is going to be your vertical displacement plus your amplitude. So we can even use that here. My range here with the amplitude of 3 over 2 means that it's going to go up to a peak of 3 over 2 and it's going to go down to a minimum of negative 3 over 2. So right away I can write my range out for this one. And that one's done. Okay, so let's go to the next page and talk about the D value, the vertical displacement. Now we're tacking on a value to the end of my sine or cos function. We call it D for vertical displacement. And we did talk about this last day as well. Vertical displacement is where your midline is shifted. A typical graph will go around the x-axis, peak above it, peak, and then minimum below it. But we can shift that line up. So you can see here for y equals sine theta plus 3, your vertical displacement is 3. That means my midline is now at the number 3, which makes sense for this graph. Here you have y equals sine theta. There is no d here. Technically it's 0. We just don't write it, which means that your midline's right at the x-axis. And then the next one we have y equals sine theta minus 2. So that means that your d is negative 2, which means your midline's right at negative 2, and that describes that graph. It just shifts the graph or slides the graph up or down, however many units you have there. Okay, so let's look at an example down here. Again, vertical displacement or vertical translation, if you have the graph, sometimes you can just read it right off of there, but if that's not easy for you, you can also take your maximum value plus your minimum value on the graph and divide by 2, and that'll give you your vertical translation. So looking at this one here, this is my D value, it's -3, which means I'm shifting that midline 3 down, sliding it 3 units down. And now I can figure out my range. Same thing from last page. It's going to be your minimum value to your maximum value. And the quick way to do it, especially if you just have an equation, is to use your minimum as D minus A and your maximum is D plus A. So in this case, my A is 1, because there's nothing written there. So my minimum value would be -3 take away 1, which means that my minimum value is going to be, whoops, -4. My maximum value is D plus A, so -3 plus 1, which is a -2. And it looks like I forgot the negative on my notes. So good thing you guys are listening to my video. Okay, so that's going to be my range there. That's the easiest way to figure out what your range is. Or you can visualize it, or if you're super stuck, draw it out and see what your max is. Go from there. So that's your A and your D and how it affects the equation. So let's look at just a couple more things and then we'll start looking at the equations. So if we go to the next page, the next big difference, I briefly mentioned it before, is if you see sine or you're seeing cos, that makes you draw your graph slightly differently. So when you're doing a sine graph, it follows this typical pattern. So you basically need 4 spots to write on here after the 0. Okay, with your sine graph, it always starts at the midline at 0, then it peaks at your next section, goes back to 0, and then you get your minimum in the next section, and then back to 0. And this is how your traditional curve will look for a sine graph. The difference with a cosine graph is instead of starting at 0, it starts at its peak, then it goes down to 0, goes down to its minimum, goes up to 0, ends at its peak. That's one complete cycle or period for a cos graph. They look exactly the same except the cos graph is shifted over 1. It starts at its peak instead of right at the midline. So knowing that bit of information, we can kind of place everything all together. So I'm going to do a couple examples here. I'll do the first one here. Here's the steps I use to draw the graph. So I'm going to give you the equation, we're going to draw the graph, and then the last example, I'm going to give you the graph, and we're going to figure out the equation. So from here, the first thing I like to do is figure out my midline. And then I like to look at my amplitude. And we'll talk about period later, but we're going to get into that in a little bit. So from this equation here, I can see that my amplitude is 2 and my vertical displacement is 1. So that means my midline has shifted up by 1. So I'm going to draw my midline first before I do my graph. My midline is here for my graph. Okay, so now I get to draw it. I'm going to look and determine now, is it a sine or cos graph? It's a sine graph, so that means my first point starts right at the midline. So I know I have a point there to start with. And then we haven't done anything with period yet, so we're going to assume we get a full period in by 2 pi. That's kind of our standard definition of a sine function. Okay, now I need to draw. So I know I need to go up, down, and then up again to end at 2 pi here. So we're going to look at our amplitude. Our amplitude is 2. So that means my peak of this is going to go 2 units up. So it's going to be at the 3. So I know at pi over 2, it's going to go all the way up to the 3. Then it's going to come back down to the midline at pi. And then it's going to go down 2 units, for my minimum. So 2 units down. And then it's going to come back up to my 0 line. So my graph is going to look something like this. I want you to fill up your whole space though. This is the trickiest part, is getting this little pattern figured out, and then you can just repeat it without thinking. So now I'm going to keep on going just to fill up my whole graph area. And I can go backwards too. And there's my sine curve. So we figured out my amplitude is 2, which is right here. And I figured out my vertical displacement is at 1. So this is my midline, that green line. Then you just have to make sure you can fit in a full revolution by 2 pi. So that means I need to plot 1, 2, 3, 4 extra points after that first initial point. So make sure you have enough space to do that to fit it all within 2 pi. If it's a standard period, you're going to have your dots at 0, pi over 2, pi, 3 pi over 2, 2 pi, like we have here. And that one's done. You can look at my cos graph if you like. I won't go through the whole thing, but notice how I started at my amplitude. You'll see your midline's at -1. But with a cosine graph, you're going to start with your highest point instead of starting at the midline. And you can see it's at a half. So that means it's going to move up half a unit and then carry on from there. Okay, so that's how you draw the graph from the function, and it takes a little bit of practice with it, so definitely work through a couple and check your answer keys and see how you do, or come on a Google Meet and I can help you out. Now we're doing it the opposite. I'm going to give you the graph and we're going to try and figure out what the equation of the graph is. So I'm going to skip down to this middle one here. First thing I like to do is draw where the midline is. It helps with all my information. I can see it goes up to this point here and down to this point here. Right in between is going to be my midline. Okay, so my midline is my d value, which I can see is at -2. So my vertical translation is at -2. That's my midline there. Now we can figure out my amplitude. My amplitude is from the highest peak to the midline. So I want to know the distance from here to here. If you can see, I have 4 notches, and it's labeled for 2 whole units after you have 4 notches. So 2 divided by 4 means we're going down by half each time. I feel like I explained that in a really confusing way, but you can see from my diagram it makes sense. So that distance, my amplitude is actually 0.5. This distance from here to here is 0.5. So now we have to figure out our equation. Those are the only 2 things we're looking at so far. So remember, your equation is going to look something like this, or this. So I have my A value already. My A value is 0.5. I'm going to double check and make sure it's a positive. If I look, my graph starts by going up, which is the way I like it. That is a 0.5 or a half. I'll label it that way. I can tell I'm starting at 0 on my midline, which means that it's a sine graph. And then I'm going to put in my displacement, which I figured out is a -2, and I'm going to tack that on to the end. So that's my equation of this graph. And you can graph it in your calculator and check as well. Then we're going to do our range. When you have the graph, it's easy just to look at it. I can see my lowest point is at -2.5, and my highest point is at -1.5. So that's going to be my range. So that one's done. Let's do the next one too, just for fun. Same thing, I always draw the midline right away. I can see my graph is all between -4 and -6, so right in the middle of that is -5. And that's going to be my vertical translation. Then I'm going to look at my amplitude. This is -5. I can see its amplitude is 1. But what I also notice is it's going to be a sine graph because the first point's right on my midline, which is great. So I know it's a sine graph, but if you notice, it's starting by going down instead of going up. It typically goes up here. That means it's been reflected. It's been flipped upside down. So that means I have a vertical reflection. So when I write out my equation, it's going to be a -1 sine theta minus 5. So don't forget to check for that negative. You don't have to write the 1 in there, I just did to show my point. And then you can see for your range, my graph goes completely in between -6 and -4. So now my range is done. The drawing is definitely a tricky part. So you can stop now if you kind of get it, but I'm going to go back and do that other graph too, just so I can explain it one more time. We'll do it on the next day as well. But after that, you should have enough information for everything. I feel like we should do one more of these. Okay, so for here, your A is a half, your D is -1, and I've already drawn the midline at -1. Amplitude is at a half, that means it's going up at a half, and it's a cosine graph, so it's starting at my highest point. Now your next point is going to be at pi over 2, which is halfway here, and it's going to come down to your midline, and then at pi it's going to be at your lowest point, then it's going to come up to your midline, and then at 2 pi it's back to your highest point. That's one complete revolution of your cosine graph, and then we can just follow the pattern to keep going for the rest of the graph. And then that one's done. Again, takes practice. We'll do more on the next day, and thanks for sticking with me if you stuck to that last example. Have a great rest of your day.